There is a broad spectrum of Internet of Things devices in education, such as interactive whiteboards, wireless door locks, cameras, tablets and e-books for the students and the teachers, 3D printers, temperature sensors, smart air conditioning systems, attendance tracking systems. All of these devices enable capturing real-time data about what happens in the classroom. Teachers, school administrators, and students can tremendously benefit from the Internet of Things. For example, by increasing student engagement, by enabling mobile learning, by being a key component of personalized education, by improving efficiency and hence reducing costs, etc. However, even though all these devices exist, the Internet of Things hasn't really been broadly applied in the education field yet. There are a number of reasons for this slow adoption of the Internet of Things in education, including security and privacy concerns. All of these devices are connected and they're collecting personal data, which of course needs to be taken care of. Costs. Unfortunately, education budgets have been significantly reduced since the economic crisis in 2008. There is also the challenge of the lack of interoperability among the different devices. There are technical barriers because many schools do not have the personnel with the technical skills to know how to operate and manage these devices, to know what to do when they break, or to know how to maintain them. There is also a lack of longitudinal studies in the educational impact of these devices, and there are concerns about many of these devices being distractions. And there is also the lack of reliable bandwidth to enable all these connections to the internet from all these different devices. Still, the potential for the Internet of Things to have positive impact in education is huge. So I look forward to seeing how the Internet of Things can help enhance, democratize, and personalize education, such that teachers, school administrators, and students feel empowered and fulfilled while enjoying their educational experience.
Currently, IoT is emerging as one of the major trends shaping the development of technologies in the industry. The rapid growth of IoT applications has increased the demand for experienced professionals in the area. In addition, higher demand in these areas infers an increased need for qualified engineers. But current undergraduate curricula offer little exposure to IoT concepts and practices. So we need a new generation of engineers that is capable of new design thinking. By cultivating the interest to build the IoT is an effort that we can play a role. Mentors, educators, and counselors, state governments, and private corporations. So we can say the more we all plan for and invest in IoT education today, the more of an edge we will reach to the interconnected world of tomorrow. In this webinar, we study essential considerations for the IoT. Also, we asked to experts in the field of industry and academia and to share their insights on current challenges of the IoT. Next sections, we will continue with an introduction to the IoT and the associated key challenge. How many devices do you have connected to the internet? Most of us have our computers, our laptops, smartphones, and tablets. Also, some of us may have a smart TV or even a game console. And there are a few of us that may have smart devices in our homes also. Smart thermostat, smart lighting, and other smart devices. It is well known the high number of regular devices connected to the internet. By the year 2020, it is estimated there will be about 50 billion devices connected to the internet. Yes, 50 billions. The stuff of science fictions 30, 20, even 10 years ago are becoming the things are reality today. We merely have to look at the cartoons from our past. The Jetsons, for example, are the first things that comes to most people's minds. Is the video phone. We have now Skype, FaceTime, video phones, and many other forms of video conferencing. The Jetsons also invented the televiewer. You were in a way to sit down in front of a monitor and read the news. It also has moving pictures. Sound a little familiar? We have taken it off the wall and placed it in your hands with the tablet that does moving pictures embedded video. And of course, this was the television watch. And now we have the smartwatches. I think smartwatches and smart cars and reminds me another television show from the 80s. Knight Rider. Of course, Kid the Car was the ultimate smart car. I look forward to the day when I am out of dinner and I am ready to leave. I can speak into my smartwatch saying, "Come, get me." My car, wherever it is, it will drive to the front of the restaurant and will pick me up. I guess we are still far from that, but evidence is already emerging. There are currently self-driving cars. Eventually, self-driving cars will have the front seats facing backwards, so that the front and back seat passengers can all be facing each other while the car drives itself. And when most cars are self-driving, there won't be any accidents between self-driving cars, because they will be all in constant communication with each other. We are in the early stages in the creation of an Internet of Things. Indeed, the current landscape of the IoT is really large. As it was said in the foreword, the Internet of Things can be seen as a distributed system of different connected objects and services, all of them connected to the Internet. The IoT is expected to make high impact in industry, and also in government, health, education, smart cities, finance, and environment. Next, we will show examples of nowadays that provide just an evidence into what is possible when we combine sensors, actuators, and network intelligence. In addition, we will see how on the consumer side there are nearly endless combinations of applications. Four key areas are examined to explore some of the most pressing challenges and questions related to the IoT. These include standards, security, privacy, and some social issues. A fragmented environment of proprietary IoT technical implementations will inhibit value for users and industry. While full interoperability across products and services is not always feasible or necessary, purchasers may be hesitant to buy IoT products and services if there is integration inflexibility, high ownership complexity, and concern over vendor lock-in. In addition, poorly designed and configured IoT devices may have negative consequences for the networking resources they connect to and the broader Internet. Appropriate standards, reference models, and best practices also will help limit the production of devices that may add disrupted ways to the Internet. The use of generic, open, and widely available standards as technical building blocks for IT devices and services, for example the Internet of Protocol, will support better usage benefits, innovation, and economic opportunity. But the reality is that we are seeing the beginnings of a trend that often impacts standards development. Certain standards groups are beginning to collaborate so that a more general standard will emerge. Naturally, the IEEE is getting into the action. In the IoT field, there is a working group to define architecture standards for IoT. The aggressive goal is to build a reference architecture that covers the ability to be integrated into multi-tier systems.
Thomas wakes up refreshed after a good night's sleep wearing his sleep apnea breathing therapy equipment, which is implemented IEEE standard 11073-10424. His sleep quality monitor also captures his sleep patterns, stages, and quality of sleep, and uses IEEE standard 11073-10423. Contemplating the data from the scale, Thomas is trying to maintain a healthy weight based upon the advice from his doctor, who will be happy with his progress. The weigh scale implements IEEE standard 11073-10415. Thomas is type 2 diabetic, and it is very important for him to closely monitor his blood sugar levels in order to maintain his health. Before he begins eating, he needs to check his blood levels with the glucose meter, which indicates normal results. The glucose meter implements IEEE standard 11073-10417. Thomas is ready for his morning run, but first he needs to check his blood pressure. He sees the readings are well within his doctor's prescribed limits, which indicates that his health routine has been paying off. Thomas heads out the door ready for his 5-mile run, implementing IEEE standard 11073-10441. His fitness monitor will help him track his activity levels. Having finished his morning regimen, Thomas is able to capture his biometric data readings on his mobile device via IEEE 802 wireless communication technologies. He then sends his data to his doctor using his mobile device via IEEE 802 wireless communications. Thomas's doctor is able to view the results of his patient's morning regimen on his mobile device and monitor biometric data trends so that he can better manage Thomas's medication and therapeutic needs. The doctor is able to see all the data from the various devices Thomas utilizes as a result of the device interoperability afforded by the IEEE 11073 standards.
While security considerations are not new in the context of information technology, the attributes of many IoT implementations present new and unique security challenges. Users need to trust that IoT devices are secure for vulnerabilities, especially as this technology becomes more pervasive and integrated into our daily lives. Poorly secured IoT devices can serve as potential entry points for cyber attack and expose user data to robbery by leaving data streams inadequately protected. When coupled with the highly interconnected nature of IoT devices, every poorly secure device that is connected online potentially affects the security and resilience of the Internet globally, not just locally. For example, an unprotected smart TV in the corner of a continent that is infected with malware may send thousands of harmful spam emails to recipients worldwide using their own home Wi-Fi. Perhaps we could unplug our internet-connected TVs if they get compromised in a cyber attack, but we can't so easily turn off a smart utility power meter, or a traffic control system, or a person-implanted pacemaker if they fall victim to malicious behavior. This is why security of IoT devices is a major challenge. Additionally, IoT devices tend to differ from traditional computers and computing devices in important ways. They have unique security challenges. Let's see some evidence. Many IoT devices, such as sensors and consumer items, are designed to be deployed at a massive scale that is orders of magnitude beyond that of traditional internet-connected devices. Therefore, existing tools, methods, and strategies associated with IT security may need new consideration. Let us focus in this issue. Some IoT devices, like many environmental sensors, are designed to be unobtrusively embedded in the environment, where a user not does actively notice the device nor monitor its operating status. As well, devices may have no clear way to alert the user when a security problem arises, making it difficult for a user to know that a security breach of an IoT device has occurred. A security breach may persist for a long time before being noticed, and corrected if correction or mitigation is even possible or practical. Once we have introduced the potential risks, a number of questions have been raised regarding security. Although many of these questions existed prior to the growth of IoT, it is essential to pay attention to this challenge because the risks increase in importance due to the huge scale of deployment of IoT devices. As said before, it's important to remember that when those devices are on the Internet, they are also part of the Internet, which means that effective and appropriate security solutions can be achieved only if the participants involved with these devices apply a collaborative security approach. Continued work is needed to evolve collaborative approaches among industry, governments, and public authorities to help secure the Internet and cyberspace, including the Internet of Things. Although all the great benefits of IoT, there are serious concerns about privacy. After all, smart devices will be collecting unprecedented amounts of data, and anything connected to the Internet is capable of being hacked. The primary privacy concerns surround the following questions. Who owns the data? The collector of the data or the subject to the data? Companies or consumers? What is done with the data? May the data be used only for the specific purpose for which it was originally collected, or may be used by third parties for marketing or other purposes? Who may access the data, and for what purposes? Certainly, your doctor should access the data for that sensor you always wear, but what about your employer? Who has control over the collection and use of the data? Sometimes an individual may not even aware data is being collected. How are the subjects at the data collection informed of the collection? How do they give consent or exclusion? The usual privacy notices found in terms of use that we all do not read are not so applicable in many situations that your sensors, since we are not even aware that the information is being collected. And many connected devices lack a user interface where we could grant consent. Of course, the Internet of Things also potentially creates a far-reaching infrastructure surveillance. As more and more data about our daily activities are being collected, it is possible to create an accurate profile of a person. How can privacy be safeguarded under these circumstances? With some of the possible approaches to safeguarding privacy interests with connected devices include the following. Anonymizing data wherever possible are required assurance for recipients of the data that will not attempt re-identification. Encrypting the data. Building privacy protections into the design of the devices from the outset. Limiting use of the data to the purpose for which it was collected. And express and informed consent. And being transparent about the fact of collection and the purposes for collection. Another protection should be to allow users to access and delete data collected by devices. And finally, providing for appropriate oversight to help ensure compliance with accepted best practices. Internet of Things offers an immense ability to track individual movements that, while potentially useful, can reduce autonomy and create a constant sense of observation. The industry should monitor the impact that information overload will have on Internet consumers of things. People do not want to hear things that will make them feel guilty, because of the fundamental self-esteem problems faced by all human beings, and that anything that breaks the illusion will result in people being exhausted with the smart devices, and simply will be disconnected. So, what do you think? Will the Internet of Things improve our lives, or will lead to a desolate future?
Well, look at the wonders of the computer age now.
That can't be true, honey. If it were, I'd be terrified.
Hi, I am Pascal Holalka working in the company Synthesis in the position of Head Innovation and Development. I only have 2 minutes to share with you my view about the security challenges in the IoT world. The first point is to understand the world of standardization. More than 150 organizations are working in the IoT normalization. The key word is interoperability. As soon as the standard will be known and published, because of this horizontal layer concerning the communication, all the players from one market will be able to come in another ones to take share. 3 important paradigms will change in a near future. The user will choose the functionalities and not the developers anymore. Think about the apps you download on your smartphone. If after the first try you dislike the app, it is done, you won't use it anymore. All the redundant functions will disappear. It means a merge of applications and cockpit to keep a big picture. And indirectly a consequence of a previous one, all proprietary systems will die. This need of usability and interoperability will destroy all the monopoles and proprietary systems. I predict 2 big changes in the security market with the standardization. The first one will be the move from static contract to on-demand ones, like you have on the TV. The customer doesn't want to pay for services he doesn't need. For example, I only need a connection to a private alarm receiving center during my holidays and not pay a bill each month for 3 weeks usage. The second one will be the transfer from external monitoring to self-monitoring. People are used to manage themselves their data, profiles, and some studies show that 55% of people expect to use their smartphone as the main administration tool for their home equipment. The security market will change into a new smart security market, a fusion of a smart home and home security. Because of the normalization, the security of the data will play a big role as already identified by the Gartner Group. If you have any question, don't hesitate to contact me. Thank you for your attention.
The current Internet of Things lack a unified standard communication protocol, which is particularly evident in the industrial field. Because these companies adopt data collection devices and application management platforms in industrial private standard, which is not in an open way. So IoT standardization is the issue, deeply rooted in the development of industrial internet that need to be solved, which involves changes in business processes, devices, and many other issues need to be addressed one by one. From the industrial point of view, the development of industrial internet means that industrial control systems will be more complex, the IT and universal.
There won't be enough business until we have enough infrastructure. So let's take the example of smart cities, for example. Now smart cities are being performed by integrators. IBM can have one city and full of sensors and perform smart parking, smart waste solutions, and control the monitor, environmental, and everything. But if we think about the new ecosystem and about the new industry we are creating, we would need a whole country with the same sensors to start enable new businesses, like, for example, trading with the data and even trading with the connectivity options for those sensor data, enabling services like apps for your smartphone that connect to the sensor network in the city and tells you if the noise levels are too high in this area or not, or where can you find a parking spot in the city. And the more infrastructure, the more players will be coming in. The more scale the market will be demanding, and the cheaper will be the chips, the connectivity chips, and also, again, the bigger the infrastructure. So I think it's taking traction, and one thing here will be making the traction to make it faster, the adoption.
According to me, the implementation of Internet of Things in the field of education has two main aspects. The first one is to use Internet of Things as a means to create an optimal physical environment where the learning process is performed. Recently, many schools and universities already use smart devices that are connected to manage and control, for example, the airflow, its quality, the temperature and humidity in the classrooms or labs, or to ensure the higher degree of physical security in buildings. So in this sense, in this aspect, I think the Internet of Things are already part of the education. But The second, and according to me, the more challenging aspect of implementing Internet of Things in the field of education is to enhance learning activities. The main purpose of Internet of Things is to create a dynamic and interactive learning environment where teachers, students and things are connected. And this learning environment must support the acquisition of knowledge in a new, more natural and efficient way that is consistent to the learner's needs and, of course, expectations. The Internet of Things has a great potential to change significantly the processes of learning and teaching and transform education into a more human-oriented process. It sounds contradictory, but in fact it is true. Recently, we as educators use more and more technical devices and technologies to adapt learning environment to our learners' needs. Internet of Things can bring many benefits, but there are some problems that arise with its wider acceptance. Problems related to standardization, security and privacy. It is very important different components of Internet of Things ecosystem to function, interact and communicate in harmony. According to me, the success of Internet of Things is highly dependent on the development of global interoperable standards. Standardization will play a significant role in how fast the Internet of Things will be taken into use of the field of education.
And as devices become more and more connected thanks to the IoT in today's internet, privacy and security have become the primary concern not only for industry but mainly for education and health. And talking about security, we have to say that typically IoT devices are wireless and could be located in public places. And in today's internet, wireless connection is made more secure through encryption. And encryption is also seen as a key for ensuring security of information for the IoT. And in addition to encryption, identity management is an important component for any security model, and unique identifiers are essential for IoT devices. And these unique identifiers can be used for established personal identity at some financial institutions or some educational institutions like universities and schools to identify illegal operations or some other functions like that. Some of the most obvious advantages of having connected campus also lead to some challenges like privacy. Having all the personal data across different areas brings up some risks of an experience that invades personal space and data. And providing transparency to users about what data is collected, for what reasons, and from whom is very important. And if a person finds out that their personal information is taken without their knowledge, this will lead to mistrust. And in addition to securing information, to make sure that it doesn't fall into the wrong hands, an issue of data ownership should be addressed so that users feel comfortable when participating in the IoT. And privacy policies could be one approach for ensuring privacy of information in the IoT. So smart objects and readers could each be equipped with privacy policies. So when they come into contact, they have to check each other's privacy policies before communicating.
The Internet of Things is becoming, maybe with machine learning and virtual reality, one of the hottest topics in the world. All the tech companies are investing heavily in the development of new devices and platforms to position in this emerging market, and obviously, education may not lag behind. However, teaching Internet of Things is anything but easy. A lot of different technologies are involved, and approaches trying to concentrate it on a single subject are destined to cover generalities. Knowledge about embedded systems covering different aspects as communications and power management are required, but also server-side applications development must be covered. Efforts to simplify the development aim at the adoption of some platforms that obviously accelerate the development, but are far away the industry, and that compromises the quality of the developed systems. And I think that must be the main requirement for future engineering quality. In my opinion, Internet of Things must be tackled during the last courses of engineering, when the student has already obtained basic knowledge about the involved technologies, with a special focus in project development. Some resources, for example, embed IoT platform, are not dependent on a single vendor, and provide all the tools required to develop not only the connected devices but also the server and client side, all the ecosystem. This allows promoting the partnership of students capable of developing innovative solutions in the field of Internet of Things, with, I think, will have great acceptance in the labor market.
For the Internet of Things, or IoT, to move faster to the education field, two fundamental elements must be taken into account. First, standardization. A lot of our IoT models are in place, but we lack a real standard model covering all the different levels involved, as IoT devices, networks, physical limits, services, processes, and user interactions. Without this standard model for the Internet of Things, learning detailed aspects is much more difficult, and only very light educational contents can be taught and or learned. Second, security. IoT delivers very significant benefits, but it also introduces very significant security challenges. Among them, a tremendous threat diversity, a greater impact and risk, changes in legacy protocols and new security protocols, a greatly increased attack surface, and the necessary changes in compliance and regulations. Without taking into account all these things, IoT will become not the Internet of Things, but the Internet of Threats, and will be unsuccessful. While all these threats to security and privacy are not solved, or at least are beginning to be solved, IoT will hardly arrive to education field.
I believe we should answer this question from two different angles within the education field. First, from the angle of delivering the lectures or improving the way we deliver the content, we deliver the concepts to our students. And second, from the perspective of the experimentation of the labs, how IoT should be affecting the way we deliver labs, we reinforce the concepts through experimentation. So regarding the first domain, the lectures, I would say that IoT must move quicker into the classroom, providing new ways to interact on the fly, on real time with our students. For instance, there are some apps already that allow students to reply to you while you are teaching, collecting feedback from them on real time and modifying the way you are delivering the message in your lecture. You open a session while you are teaching, or while you are delivering your lecture, and you can survey them and you collect that feedback from them immediately, modifying the way you are delivering the message, improving your message. And regarding experimentation, we can have flip labs in the sense that now the lab in small devices, in IoT chip devices at home, students can perform the experimentation and just to the bring the results to the lab. So having a discussion lab rather than experimentation lab. That will also allow students to improve the way they are learning. And thanks to technology, thanks to small devices that nowadays are available within this IoT world. So I think those are the two angles that we should look at it. I would like to add another domain as well about the challenges that scalability brings into this whole picture. How scalable these IoT solutions, will be towards education. So, first of all, security and privacy, it's already a big concern within the IoT domain, within the IoT community. Um, from the design phase, several concerns have arisen, and just some of them are being addressed currently. Um, from the design and from the way IoT should work. Now, if we extrapolate these issues into the education, we have the same answers, the same questions, I should say, not answered yet. It's a big issue regarding security. It's going to affect um, the way we deliver material. And regarding privacy, I think that's the most important issue. It's going to really need a lot of focus from the policies that universities, that lecturers need to apply or need to modify in order um, to provide a safety environment for our students while using IoT technologies. And regarding scalability, how scalable these solutions would be. Can we increase the size of our classes? If we increase the size of our classes because IoT devices allow us to do it, maybe we're going to decrease quality, or hopefully we are going to increase both things. We can scale our classroom, also scaling, extending the quality. Those questions need to be addressed within the educational community. I must say that within IEEE, we are already addressing these new changes. For instance, there is the standard, it's a working group that's working on the standard P1876, which is the standard for networked smart learning objects for online laboratories, that it's designing the whole framework in order to standardize how online laboratories should interact, in particular with the equipment, with these smart objects, with these IoT objects, and how a common layer, a common framework should be should enable um, proper online labs. So definitely, IoT, it's changing the way we teach. It should change faster, as we mentioned in a previous question, and the educational um, community, it's addressing those changes. These challenging changes are being addressed in a very professional way through different standards, as the one I commented.
The concept of combining computers, sensors, and networks to monitor and control devices has been around for decades. In this webinar, we have made a trip through past, present, and future of the Internet of Things with applications in industry. We have shown that IoT represents a growing aspect of how industry can interact with the Internet and network connectivity into personal, social, and the economic lives of the people. Also, we have seen evidence about how the recent confluence of key technologies and industry trends is helping in an encouraging future for the Internet of Things. We have covered a number of potential challenges for emerging industry that may stand in the way of these visions, concretely in the areas of standards, security, privacy, and social issues. Solutions to maximizing the benefits of IoT while minimizing the risk will not be found by engaging in a polarized debate that pits the promises of IoT against its possible perils. Rather, it will take informed engagement, dialogue, and collaboration across a range of stakeholders to plot the most effective ways forward. So we have promising challenges for mentors, educators, and counselors. Let's see the most important. Firstly, take advantage of the opportunity and responsibility to teach students how to design IoT products and systems. Next, incorporate new subjects in order to provide the skills that are necessary in an IoT business world, where analysis of this data from IoT sensors will take on a major role. Thirdly, teach the base modules of the IoT, for example, Arduino or Raspberry Pi. And finally, and most important, inspire creativity to apply the IoT to new business and concepts and a vision of where the IoT can lead. About other applications of IoT to education field, campuses can often be viewed like cities, and some of the greatest IoT innovations today are found in smart cities. Leaders in this space have key goals and improve access to citizen services, very similar to the objectives of many universities. To achieve those goals, higher education institutions can learn from leading smart city innovators. They can transform into fully connected campuses. Finally, this webinar has gave evidence of how Internet of Things is creating entire new industries. Consequently, the best place to start is by giving educations in Internet of Things. Hope to see you soon during the rest of webinars. To get further details or even make any questions, please do not hesitate to reach to us through the following contact details.